We have a 75 kg astronaut in is or he or she is performing maintenance on a space station. To return to the station, she throws a 2 kg wrench away from the station at a speed of 10 meter per second. What is the recoil velocity of the astronaut? So we have an astronaut and okay, let me draw the hand stuff. And she happens to throw a wrench. She threw it. And because of that, she gets pushed back towards the space station. Okay. She herself is 75 kg with the bag and everything. And this is 2 kg thrown at a velocity of 10 meter per second. And we have to figure out what is this velocity. That's it. What do we use? Yeah, what do we use? Of course, you guys will be answering this using conservation of momentum. So, as per conservation of momentum, what do we have? The initial momentum should be equal to the final momentum. Initial momentum is 0 because before throwing, nothing is happening. Final momentum is we have ma va, right? Mass of the astronaut into her velocity plus mw vew. Okay, I can put final also, but I think this is simple. Now, if I consider right as positive, right and up as positive, so we have 0 is equal to, this is the mass, velocity is unknown. This mass will be 2 and this is minus 10. And so VA is equal to a simple calculation. You guys can do that. So many meter per second. Now, there's another case. So this is A, by the way. If the wrench, okay, is thrown at an angle 30 degree to the line connecting the astronaut and the stationary and station and all of those. So I'll do this. We have the station, we have the astronaut, and we have a line connecting them. Something like that. Not exactly. Not exactly. Okay, something like this. So instead of throwing straight away, she threw at an angle of 30 degree. See over here. This is 30 degree, right? And what else we have? This is your station. And that's your astronaut. Now, same thing. This is also 10 meter per second, so on and so forth. But will she be able to reach the station? I guess so. But will it be with the same rate, with the same time? No. She will take few more seconds. Why is that? Because the velocity, because of a throw, she will travel in this way, basically. You know? So she will travel that way. Or you can think of that she got displaced this way plus this way. So basically, she is going to move at whatever speed is contributing to this direction. That is the speed with which she will be going. So how do you figure that out? Well, for that, we need to figure out what is the velocity along this direction. So this is 10 meter per second. This will be, this is cos of 30 is root 3 by 2. And so this will be 5 root 3 meter per second. Again, this is nothing but resolving of vectors. If you didn't understand this, you need to watch basics. Okay. Vector basics. So this we understand is 5 root 3 meter per second. Everything else remains the same, right? Again, we are going to make use of as per. Actually, this is the answer starts here itself. Right here itself. Okay. So this is B. Now, as per conservation of momentum, what we have here is 0 is equal to VA into MA plus VW into MW. But this is what? This is parallel to the line connecting, like parallel to say AB. I'll just call this as AB, parallel to AB. Again, guys, it is this velocity that will help her reach, right? Left to right. It is that velocity which will help her reach. That's why we have to take the parallel component parallel to AB. Okay, so if you guys didn't get that, let me write this is parallel to line connecting the station and the astronaut, AB. That's for your understanding. You need not write in exam, or you can write it, not an issue. If this gets lesser and lesser, this parallel component, if she had thrown this way, okay, let me ask you this question. If she had thrown this way, do you think she would have reached the station? If this was the station? No, right? She would have gone this way. She should have gone flying this way. Should have been lost forever, actually. So please understand that it is the parallel component that will contribute her going to the right. The perpendicular component will give her an angle. Basically, she'll go this way. But this is the rate that we have to consider, because she has to go to the right. And now it's same set of calculations and we are done. So this is what we have to figure out. Mass is 75 kg minus 5 root 3 times of 2. And whatever this answer is, minus meter per second. So again, negative indicates both the places. Negative indicates, oh no, sorry, positive. Positive indicates she moves to the right. Here too, positive value is what we get, and indicates that she moves to the right. It's positive only, right? Yeah, I'd taken left as negative, right as positive. So the question is, they are asking us to compare. For that, I need to calculate. So 75 divided by 20, it's a simple calculation. But let me use calculator. Okay. No, oh, sorry. Thinking 20 divided by 75 is... Okay, sorry guys. 0.27. Actually 26 bar, but not 27 bar. This is an approximate value. While here it would be, this would be positive by the way, 510 times of root of, oh sorry, no, root of 3 divided by 75. So this is, you can see clearly 0.23. So her velocity is less, means she'll take more time to reach. As simple as that. 3-1, but yeah, perfect. Approximately this. So what is the question? How much this affects her recoil velocity? 0.04. So astronaut, she is her recoil velocity is her recoil velocity is reduced by an amount of 0.04 meter per second. Okay.